Right. Everybody seeing this, right?
Yes.
Alright. So as I say, this is just a review. We just and for those of you guys who were with me from last year, you all might be familiar with some of these slides. You could tell that this year I'm not using these slides to teach. Instead, I'm using these slides to summarize. So these slides contain a summarization of everything that we've been doing in the last 10 classes. And we were doing algebra, and as we said, algebra is a language, and it uses unknowns. It is the language that, and like what Scotia said, we could find unknowns, but sometimes you could only find an unknown if it have one unknown in the equation. Then you could solve it. But if you have more than one unknown, you're pretty much, you have no hope. You can't solve an equation with more than one unknown, right? So it's not just about finding unknowns. Sometimes you could manipulate unknowns as well, and we'll see what that's about. So we started off here with just some simple little things that we have a missing number, and instead of putting a box, we could actually use a symbol, whether it's X or Z or P or Q or phi or whatever. We could use alpha and gamma, beta, all them kind of things, right? So you could use any symbols, but they just represent an unknown. That's all. And we see here that we have some unknown minus 2 is equal to 4. Well, you know that in this case, we just want to add 2 to both sides of the equation. And that'll get rid of this 2, and we'll end up with x is equal to 6. Now, I hope that everybody here is okay with this level of algebra. And we were seeing here that we have to think about this whole thing like a scale. This side must be equal to this side. So therefore, whatever we do to one side, you have to do it to the other side in order for them to remain equal, right? And in this case, we are minusing 2 to get rid of this plus 2. So now we'll have x is equal to 6 minus 2, x is equal to 4. So we're thinking about this thing like a scale. We have x plus 2 on one side, and we have the 6 equals, x plus 2 equals 6. And if we remove 2 from one side, so the 2's are gone here, right? The scale will be unbalanced. So you need to remove 2 from the other side as well to get x is equal to 4. So it's pretty much a scale is what we're thinking about it right now. And we have a little scale exercise here that's kind of fun. So let me see. Can I click this? No? Alright, so you guys, so let's just try this exercise. Copy. Alright, so check out this exercise here now. Yeah. So we have a scale, and on this side of the scale, you see, we have 2 x's and then 2. 2x plus 2. And on this side of the scale, we have an x and a 4. X plus 4. And what we could do, we could add x's, we could minus x's, we could add 1's or minus 1's. So let me just do this. We want to find what x is. We want to solve for x. So what I'll do is let me minus x. I see I have 2x on this side and I have x on this side. So let me minus x from both sides of the equations. So if I minus x from both sides, and I take out an x from both sides if you notice. So I only have one x left here, and well, that's equal to 4. So I have one x left here. Now I need to get rid of this 2. So I'll minus 1, and then I'm going to minus the next one. And now the equation is balanced here. We have x is equal to 2. You guys understand how to do this little game? No?
Yeah.
Alright, well, let me see. What to do with this one now? Remember, all you could do here, you have the scale. So you could add x's or you could minus x's. You could add how much you want or minus how much you want. Or you could add 1's or minus 1's. And you could do that any amount of times. So tell me what to do.
Add it.
add, okay, so let's add 1x. So if I add an x, well, we see the x here disappears, and I have just 1x again on this side, but it's a negative. So because it's a negative, let me add an next x. So if I add an next x, you see I'll have a positive x on this side, and this negative x will disappear, right? And now let me minus 2. So I go minus 1 and minus 2, and x is equal to 6. So we have a nice little game here, and you guys could actually click on that game and try it. It's a nice cool little exercise. You all could check it out, right? You'll find it in the slides here. It's a wonderful, cool game. Right. So we were talking about how do we actually add or do operations with algebra, with unknowns. Well, if I have two of the same unknowns, I can add them. So if I have an unknown number of apples and an unknown number of apples, I can add them to have two, sets of apples, right? If I have two sets of apples and a minus one set of apple, I could just have one set of apples left, right? So once we have the same unknown, the same number, we could add them and we could subtract them. But if we have different numbers, if I have an unknown number of apples plus an unknown number of oranges, then you can't do nothing with that. I'll just have apples and oranges. Yeah, same thing with the minus. So once you're dealing with different unknowns, then you cannot do anything with them. In terms of multiplication, not much could really be done. If I have an unknown number of apples and I multiply that by 2, I'll have 2 times the unknown number of apples. Right? If I have an unknown number of apples and I multiply that by the same number of apples, it must be the same. Well, I can add my indices. So I'll have that unknown number of apples squared. However, if it is that I have an unknown number of apples and I multiply that by an unknown number of oranges, nothing changes. The only thing that changed here is that I could write it differently. Because multiplication, look at this. I have 2 times the amount of apples. So multiplication, this kind of form a single unit. And I want you guys to remember that. So because of that now, I could write it as a single unit. But really and truly, it doesn't change anything. XY simply means X multiplied by Y. Nothing has changed. Right? Same thing with division, right? I can't do anything if it have 2 different unknowns. I can't cancel it off. I can't do nothing like that. All I could do is write it differently. Yeah? So, dealing with same thing we were just talking about here. If it is that we have X multiplied by 4, we could write it as one single unit, 4x. And then you just divide both sides of the equation by 4, and you will get x alone is equal to 2. Ariel, Shazay, Caitlin, Scotia, are you guys okay with everything that we did up to this point?
Yes, sir.
Ariel, you alright?
Yeah.
Alright, nice. You're going okay there?
So far, but I think I need to go to the classes. I still have some classes to go to. So.
Absolutely. Yeah, well,
I understand so far.
You understand everything that we're talking about so far, right?
So far, yeah.
Alright, well, if you have any problems, even though it's just a review, if you have any problems, just stop me. Let me know, right?
Okay. Yeah.
And that goes for anybody. Now, this here is a really important thing that I'd like everybody to consider. If you have half of a cookie, then that is the same as a half multiplied by that cookie, which is the same as the cookie on 2. Now, this is something that is supremely important that a lot of students just can't figure out. That if I have a fraction of z, I have a fraction of z. So what that really means is I have a fraction of z. And remember, this is z over 1. So I can multiply my numerators and my denominators, and I could have a fraction of z being written like this. And I could also write it like this. And I could also write it, split it up all kind of ways. And all of them is the same thing. Now this is a really super important thing in algebra when it comes to the multiplication of fractions. And you can see here that it just basically comes from the simple little arithmetic law. And I keep saying that the main problem with algebra is simple arithmetic. So in this case we have another illustration where I have a half times x, and that could also be written as a half x, which is also x on 2, right? Remember, a half times x is a half multiplied by x on 1. So your numerator and your denominator, and you get x on 2. Same thing over here. 2/3 of x could be written as 2/3 x, or you could just put the x in the numerator, 2x over 3. Right? And I could also split this up to have a third times 2x. Or I could split it up again to have x on 3 times 2 if I wanted to. You know, they're all the same thing. And understanding that they are all the same thing. So Ariel, do you understand that they are all the same thing?
Yeah.
Right. Ariel, I want you to tell me the very minute that you start to get lost, right? Because we're moving fast with this one, yeah?
Okay.
Alright, remember this is just a summary. So once you start to get lost, let me know one time. That goes for anybody, right?
Okay.
So we have a nice little exercise here. So let's all just try to do this one here. So what do we have? We have minus 3y minus 2 is equal to negative 8, right? What we want to do is we want to solve for y. So how do I do that? What's the first thing I should do?
Transpose the minus 2.
Transpose the negative 2. So I can have negative 3y is equal to negative 8 plus 2. Negative 3y is equal to negative 6. And then what?
Divide both sides by negative 2.
Right, in other words, transpose the negative 3. So I'll have y is equal to negative 6 divided by negative 3. You notice the sign did not change. It's still negative 3, right? So the rule is, well, just now we'll talk about the rules when we talk about transposition, right? But essentially y is equal to 2. So Ariel, you okay with this? Caitlin, you okay with this?
Yeah.
Yeah.
Nice. Okay, good. And we keep on going. So when we're talking about transposition, are we talking about the same thing? We keep talking about flinging things across, like take this tree and fling it across. But really and truly what we are doing is we are transposing the 3. So you transpose the 3 and the 3 becomes negative 3. Now why does it become negative 3? Well, because we minus 3 from both sides of the equation. That is what we actually did. Right? Now, at the end of the day, you could simply remember it like this. If you have an addition on one side, remember this equal, once you cross the equal sign, you're going to be opposite. So if it's an addition on one side and you throw it across, it'll become a subtraction. Yeah? If it's a multiplication on one side, right? If it's a multiplication on one side and you throw that across, it's going to become a division. Right? So this is just remembering in terms of transposition that once you fling in something or you're transposing something across the equal sign, then the opposite is going to happen. Right? If it was an addition, it's going to become a subtraction. If it was a subtraction, it's going to become an addition. You notice here, this positive 2 remained a positive 2. The sign did not change because the opposite here was not addition and subtraction. The opposite here was multiplication and division. So just be careful, because some people will make the mistake of putting -2 here, and that's not correct. Remember, to get rid of the 2, we had to divide by 2. Right? And that is the reason why we end up with the +2 across there. Ariel, I'll say it? No?
No.
Alright, good. Good. Right? So, we cannot solve an equation with more than one unknown. And this is what I was talking about when Scotia was saying is about solving things. Sometimes you can't solve things. Right? Sometimes you're dealing with more than one unknown. But at the end of the day, when you have an equation with more than one unknown, we can't solve it, but we could mess with it. We could manipulate the unknowns. So we could take this 3y here now and transpose it and fling it across, and it'll become -3y. And then we could take the 2 and fling it across, so it'll become divided by 2. Ow, just now my leg cracked. Ow. Sorry. And now we can see here that we have made x the subject of the formula. So we didn't solve anything. This is actually the exact same thing as this. They're both the same. They're just different ways of saying it, because it's a language. So they're both the same, but we could say it in different ways. And in this way of saying it, we have x as the subject of the sentence. Yeah? So we could make x the subject of the formula. Caitlin, you okay with the subject of the formula stuff, right?
Yeah.
Alright. Well, since all you're okay with the subject of the formula stuff, let's take this example here. Right? If I have, and I'll just write it, what we want to do is we want to make c the subject of the formula. So I'll just flip the equation. So I'll put the b squared is equal to, not equal to, sorry. Oh yeah, I can't undo that, boy. For real? Just now. Discard. Yes. And start over. Right. So we're gonna have this guy. Crap. Yeah. We're gonna have this guy here. And we're gonna say b squared minus 4ac. So I'll put that on that side. And I'm gonna put equals and I'll put the d on this side. Right? So now I want c to be the subject of the formula. So what am I going to do first? What should I do first here? Alright. Can I transpose the 4a?
Can you do what?
Can I transpose the 4a?
Yeah.
No, you can't really do that. I mean, you could, but it would be incredibly hard. At the end of the day, this 4ac is being minused from the b squared. So I can't just pull that 4a out of there. Yeah? And at the end of the day, this 4ac is a single unit because it's all being multiplied. Right? It's a single unit. So what I want to do generally in these kind of situations is you want to start far away from the c. Whatever it is you want to make the subject of the formula of, you want to start far away from it and then get closer and closer to it. So yes, I'll have -4ac is equal to d, and it was positive b squared on this side. So it'll become -b squared on this side. Right? So what to do now? Right, the -4a. It's multiplied by -4a. So I could now say that c is equal to d minus b squared, and all of it will be divided by -4a. Alright, so Caitlin, you okay with this?
Yeah.
Alright, Ariel?
Yeah.
Shizzy, you good?
Yes, sir.
Alright, yes. Let's see if we can do this fast. I know people busy, come from work, might be tired and things. So here what? Let's just do this one. Alright, we have to make t the subject of the formula. So the first thing I would do is to flip the equation. So let's just flip the equation, and I'll put t plus p all over r, and that is equal to 3q. And I don't want Scotia to answer this time, because Scotia seems to be on the top of her game. So somebody else, tell me, what should I do first? You're making t the subject of the formula here.
You transpose the r.
Right. Can I transpose the p? I mean. Caitlin, can I transpose the p?
I don't think so.
Yeah.
Because I'm still bracket.
It's in brackets, and it's all that. The t and the p, both of them are being divided by the r. So that p has things that being done to it. So you can't mess with it. It's not by itself. You know? So you definitely have to move the r, transpose the r, so it'll become t plus p. There is no r anymore, so I don't have to put no brackets. And that is 3q multiplied by r. So I can write it as a single unit. And now, of course, elementary, t is equal to 3qr minus p. You okay, Ariel?
Yeah, but I thought that you could transpose the p, but then I understand because it's in a bracket and divided by r.
Yeah. No, yeah, it's not only that, but if you look at this situation here now, right, where you have to make t the subject of the formula, t plus 3 is not in our brackets, but all of it is being divided by 7, and so you had to take a look at that. You can't just go and throw that 3 across. That 3 is being divided by 7. Yeah, so you had to throw the 7 across first. T plus 3 is equal to 7g, and therefore t is equal to 7g minus 3. Yeah, now you could throw the 3 across. Oh, you cool, Ariel?
Yeah.
Alright, just checking, just making sure. Now, Ariel, those classes that and you and Shazay, those classes that you guys missed out on were the most important classes in the whole curriculum, eh? So all you make sure and catch up, because we go into detail when it comes to how to deal with these kind of fractions. And what do these kinds of fractions mean? Like Ariel, you are supposed to recognize that if you have t plus 3 all over 7, that is the same as saying t over 7 plus 3 over 7. Right? So now I could say t over 7 plus 3 over 7 is equal to g, and now I could throw the 3 over 7 across. Yeah? So you are supposed to recognize this, and you see things like this, Ariel, we went into these kind of things in detail in those classes there. So Ariel and Shazay, make sure you catch up with them classes, Drew. Them classes super important, right? Right. Worded problems now, right? You all had a question? No?
No, sir.
Okay. Worded questions now, right? We took a look at worded questions, and we were saying, you know what? All right, let's take this first one. X plus 2 is equal to 6. And I want to take this and I want to create a worded question. So what I'm going to say is, you know what? I have 6 mangoes in a bag. 2 of them was good and the rest rotten. How much rotten? You see how I turned that and how I took that and I turned it into a worded question. Right? You could do it in many other ways, right? You could have 6 students go into the zoo. 2 of them went by car and the rest of them went by truck. How much of them went by truck? You know? So you could take this and turn it into a worded question. So here's what I want everybody to do. I have 3 people here, so I should get 3 different worded questions for this equation. How much time all you want? 2 minutes?
3.
3 minutes. All right. 3 minutes. Take that and turn it into a worded question. And I'm hoping to hear 3 very interesting worded questions here.
Okay. This one is second in box, right?
Yeah, this one here. Yeah.
I had Patsy bought 11 hats. She gave 11 to her sister. The remainder of the hats she gave to 3 of her people. How many hats did she give away?
She had 11 hats. She gave 11 to her sister. That's what you say? She gave 3 to her sister. And the remainder of the hats she gave to 2 different people.
Yeah.
Right, but you have to explain that those 2 people got the same amount of hats. And?
Yeah.
Because what if she gave one set of hats more than the other? You understand? Alright, so yeah, that was a nice attempt, except for that little hiccup there. So when you're writing a question, you have to be real careful, because remember, you don't want a student to misinterpret the question and do the question wrong, right? That was a nice attempt. Anybody else?
I had almost the same thing that Scotia had, but I used dogs.
Alright, so let me hear what you had.
11 dogs gave 3 away. And how many dogs did they remain?
How many dogs did they remain with? So you have this entire thing being a variable. So you have, that could have worked if you had y plus 3 equals 11. So you have 11 dogs, give 3 away, and how much dogs you remain with, yes? Alright, so how much dogs you remain with in this case would have been 2x. Alright, so therefore you're not finding for x, you're finding for 2x. You understand what I'm saying? Right, so be careful with that, right? Anybody else?
I had 11 children, job of care, 3 children bought books for 2 times the sister number did not. How many children did not purchase any books?
2 times the sister. I mean, yeah, 3 out of 11 bought books. It have a lot of things that are a little off about that, but that's a good attempt. A good attempt. What I don't like is 2 times the remainder of the children. That's what you're saying. The problem is that 2x is the remainder of the children, so not 2 times the remainder of the children. Right, Shazay, you have one for us? Good attempt, though. Nice try, guys. Nice try. I love what I'm hearing so far.
So honestly, I tried something, but it sounded so whack.
Let me hear it.
You have 11 cars in total. 3 are red and 2 are blue. The remaining color is a mix of 2 blue cars and a mystery color.
So here's my problem with this question, right? First of all, it's real long. Keep it simple. Keep your question simple. Next thing is, you have 11 cars, 3 red, 2 blue, and then some unknown number that is some other amount, some other color. So I don't understand how you could take 2 blue cars and multiply it by the unknown color of cars. You get what I'm saying? Right? Yeah, but that was a good, sorry, what were you saying there, Ariel? Yes, but watch how easy it could be though. Let me give you one, right? I went to the supermarket with $11. Oops. And I'll show you, I'll see where I'm going with this one. I went to the supermarket with $11. I buy 2 soft drinks, right? And I get $3 remaining. How much was for 1 soft drink? Remember, you want to find for accent.
Yes, sir.
Yeah. So so it is quite of an art. What I didn't like about yours, Shazzy, is that you had 11 cars, but this set was red, this set was blue, this set was green. You know, at the end of the day, no, you want everything to be the same. Yeah. So in this case, remember, in this case, I have 6 apples in a bag. 2 of the apples was good and the rest was rotten, but still everything here is just apples. Everything. It had no different kind of apples and thing here, like how you kind of had, you know, different types of cars here. I mean, what you was doing was, and you know what was the problem with all earlier? The problem with all earlier is that all earlier was thinking too much. You all made it too complicated. Yeah, you know. How about 11 children going to the zoo, right? And same thing, 3 of them went by car, and the rest of them took 2 buses. Yeah. So how many kids went by bus? Yeah. So yeah. Right. So everybody going to do this one. Number 4. I'm gonna give you an additional 3 minutes. Now Ariel and Shazay, all you're gonna real catch all your tail, right? But at the end of the day, Caitlin and Scotia, you guys are supposed to be able to do this because we did this in class. Right? We did questions like these in class. So here what? Do number 4 and do number 2. So number 2 and number 4, these are worded problems. So what you are expected to do is you are expected to take this. You see how just now we took an algebraic expression and we formed a worded problem? Well, now you have to take a worded problem and form an algebraic expression. So I don't really care what the answer is. I just want to hear what your algebraic expression is going to be. Right? So 5 minutes. Right, so let me get. Where's the expression for the first one?
I had 7x for 24 months.
Yes, but at the end of the day, you take the total. So Aliyah had $24. So you take the total and put it on one side of the equation. She had $24. That's the total amount of dollars that she had. Right? So what else did she have? To spend on 7 pencils, so 7p, right? Or you could use X or whatever. After buying them, she had $10. So 7 pencils plus $10 is equal to the total of 24. And that is it. And I think everybody could solve for P there, right? Ariel, you okay with this?
Yeah.
All right, nice. What about number 4, Ariel? Any ideas?
I also find
Anybody have any idea what to do? Scotia and Caitlin, are they supposed to know this one? You know, Caitlin, let me hear you.
I didn't finish them before.
But did you get an expression? I don't want the answer. I just want an expression.
Not yet.
All right. So this, yeah. Sorry, Scotia, what you were saying?
I wasn't saying anything.
Okay, Shazay, any ideas here?
I can try.
All right, yeah. Y and Z, and that is equal to 48. Right, you're on the right track. The problem is that I have 3 unknowns. There's no way I could solve that. Yeah? You want to have 1 unknown. So you want everything to be in terms of x. You understand? So, but that is good thinking though. You know you have 3 numbers. You know you have 3 numbers. X plus y plus z. And that is equal to 48. But let me analyze it. They give you, look at the words, worded problems, and this is what we're saying. You can't have a very long question, even though this is quite long. But each word must be important. Each word must be a piece of the puzzle. So we have 2 things here. That there are 3 consecutive even numbers. So the 2 clues is consecutive and even. So if it is that we have an even number, let's just say 2, right? Then the next even number is 4, which is the even number before 2 plus 2. And if you want the even number after, you had to take this one, the 4, and you had to add 2. If you want the even number after, you had to take that 6 and add 2. You get what I'm saying? Ariel?
Yeah.
So, if it is that my first even number is x, then the second consecutive even number would be that first even number plus 2, and then the next even number would be this even number, x plus 2, but then you're adding another 2. And that is equal to 48. You understand that, Ariel?
Yeah.
You understand the reasoning? So the whole point is that you look at every single word. Every single word means something. So now, in this case, I can remove the brackets because nothing being multiplied here. So now I have 3x plus 2, 4, 6 plus 6 is equal to 48. 3x is equal to 48 minus 6, which is 42. X is equal to 42 divided by 3, which is what? What's 42 divided by 3? 14. So now you find the first number, which is 14. So therefore your first number is 14. Your second number will be 16, which is 14 plus 2. And then 14 plus 4 is 16, 17, 18. 14 plus 16 plus 18 will give you 48. You can check it in your calculator. 14 plus 16 plus 18 is 48. Alright? So then we talked about substituting values now. So we said that if it is that we have an expression, x plus 3, sometimes they will tell you what x is. And all you have to do is, in case when they say x is equal to 3, you just take the 3 and put it into the expression. So x plus 3 will become 3 plus 3, which is 9. In this case, this is the expression, and they tell us that x is equal to 5. Remember, you cannot solve an expression, and we'll talk about that just now. You could only solve an equation. This is not an equation, this is an expression. So they have to tell us what x is. When you know x is 5, you just put that 5 into your expression. You put the 5 wherever you have x. So 2 multiplied by x will become 2 multiplied by 5, which is 10 plus 3. Wait, that shouldn't be 3, that should be 5, sorry. So there's a little error here. This should not be 3. So it's 2 times 5 plus 5, because this is 5 over here. So the answer is actually 15. So this is quite an error. Sorry about that. Right? But I'm hoping that everybody, so Caitlin, Ariel, you all okay with substitutions, right? Alright.
Yeah.
Shazay, you good?
Yes, sir.
Right, and of course we have some substitution questions here, but I'm not gonna bust out their brains with it. We have a lot more substitution questions here. And lastly, please know the difference between an equation and an expression. An equation, equa has an equal sign. An equation has an equal sign. And if you're just dealing with one unknown, then an equation can be solved. If you're dealing with an expression, you have no equal sign. It is not equal to anything. So therefore you cannot solve this. Right? Right, so that was Algebra 1, Introduction to Algebra. And now we're talking about Algebra 2. We're continuing with our Introduction to Algebra here. And remember, these are everything that we did in the last 10 classes, right? One of the things we were talking about is the distributive law. Right, oops, sorry. And we can see here that the distributive law, if you have a number A multiplied by an expression in brackets, all you do is you take that A and multiply it by everything in the brackets. So you'll get A times B is AB plus A times C is AC. So you guys understand the distributive law, right? A times B plus or minus, sorry, A times C. Right? So at the end of the day, we have an example here. 2 into this expression is equal to 1. I can multiply 2 times x to give me 2x, and 2 times 5, which will give me 10. So now I have a full equation that I can solve. Yeah? And we have some more. So let's just do this one really quick, number 5. Right? What do I have here? I have -8 times -4 minus 3n. So what do I do first? Anybody? Right, the first term. So 4 8s are 32, and that'll be positive 32. And then what to do after that now?
Multiply -8 by negative.
Right, 8 3s are 24, and the 2 negatives will give me a positive 24. And Ariel, I lost you yet? Yeah, I lost you. All right. So and you know how you also you understand this page, right?
Yeah.
Right. So you understand that you're just taking the number on the outside and multiplying it by everything on the inside, and?
Yeah.
All right. That's all I did here. That's all I did here. I take the -8 and I multiply it by the -4. That's the first thing that I do. So 4 8s are 32, and remember, a negative times a negative is a positive, eh? So -8 times -4 is positive 32. And then that is minusing -3. Sorry, that minusing 3n. So I'm taking this -8 and I'm multiplying it by the 3n. But remember, that is a -3n. So again, -8 times -3 is positive 24n. You understand now, Ariel?
Yeah.
Alright, not lost anymore, right?
No.
Alright, good. Remember, the minute you get lost, let me know, because I wouldn't want you to, to get lost. Now, we actually did not do this, right? But I could just touch on it now. It's really, really simple. Even though we have different unknowns, it's an expression, we can't solve it, but we could factorize it. Factorizing means you're doing the distributive law in the other way, the other direction. So before, we had this brackets here, and we expanded the brackets to get -6a, and 6 8s are 48, so that's minus 48. Right? So you can see we have one expression here. We took the brackets and expanded the brackets in order to get one expression. Over here, we have one expression and we want to separate it into brackets. So let me ask you something. Are there any factors that are common between these two guys here? 12. Very good. So I could pull 12 out And I could say that this is 12. If I pull 12 out and I open brackets, 12 times x will give me 12x. Yeah? Plus, because I have a plus here, and 12 times 2 will give me 24y. Right? So now I have 12 outside into x plus 2y on the inside. Ariel, you okay with this one?
Yes.
You could give me this one here now?
Yeah.
Alright, 12p plus 36q, factorize that. What do I pull out? What is the common factor there?
12.
Very good. So I could pull out 12, right? Right. So 12, right, open brackets, times p, and?
Yeah.
And then what? Plus what?
Plus 3.
Very good. 3q. Because 12 3s are 36. And? Right.
Yeah.
So excellent. Now, I want to make a note of something. We had 12x plus 24y. And we pull out the 12, as you can see here. And this is correct. Now, it has some other things. We don't have to pull out 12 alone. We could have pulled out 2. If I pull out the 2, then I would have had 6x here. So 6 2's would have given me 12. Plus 12y. 12 times 2 would have given me 24. But this, even though it's mathematically correct, it's still considered not good. The reason why it's not good is because when you pull out the 2, you still have these two guys with common factors inside of here. So inside this brackets now, these two guys still have common factors. So I could pull out a next 2 if I wanted to. Or I could pull out a 6 from inside of here. Yeah? So these two guys now, they still have common factors. So you don't want that. What you want is that when you pull out your factor, inside of the brackets have nothing in common. Everybody understand that? Shazay, you okay with that?
Yes, sir.
Caitlin, you good?
Yes.
Alright. Now we also looked at how to multiply these double bracket things. Right? And as I say, we did this in great detail. This is just a review. But so if you check back at those classes, we take the time with it. Where you're just really taking the A and multiplying it by everything in the next brackets. You seeing that, Ariel?
Yeah.
Right? And then you're taking the B now and multiplying it by everything in the next bracket. And that's pretty much all you need to do. Yeah? And of course, we do have some questions here, and I have some nice, tasty, hard questions that I'm not going to bust all your brains with tonight. Don't worry. Yeah? So you do have to, but I should, should I? Let me see which one I could give all your brain. You think I should bust all your brain with one or not? Move on? Everybody good, or you want to try?
I like your brains.
You like your brain? Okay. That is good. I could have gave this one here with all of the negatives. Let me try that one. Negative x minus 7. Negative 3x minus 2. What are we going to be doing with this one here now?
Multiply these negative x by negative 3x.
Right, so multiply the negative x by everything in this bracket here.
Yeah.
So I'm taking the negative x times negative 3x. So what is negative x multiplied by negative 3x?
3x squared.
Very good. Positive 3x squared. Yes? And then I'm taking the negative x now and I'm multiplying it by negative 2. So where's negative x multiplied by negative 2?
Positive 2x.
Positive 2x. Right, so I finished with the negative x. Now let me do the negative 7. So I'm taking the negative 7 and I'm multiplying it by negative 3x. So where's negative 7 times negative 3x? Positive 21x, very good. And then I'm taking the negative 7 and multiplying it by negative 2 to give me positive 14. And well, I can't add x squared to any of these, but I could add these two because that is x and x. So 21 plus 2 is 23. So now I have 3x squared plus 23x plus 14. Ariel, you lost?
No.
Alright. Okay, very good. Good job, right? Now this was another one that we spent time on. We were saying here, remember, that x squared is 25. Meaning if you remove the square, you'll have to put a square root sign on the other side. So x is equal to the square root of 25. And I'm not sure if Ariel and Shazee was here for this class. I think they were, maybe. Or maybe just Shazee. But we saw that the square root of 25, a lot of you guys thought it was just 5. But no, it's not just 5. It's actually, it could be positive 5, or it could also be negative 5. Because negative 5 times negative 5 will give you positive 25. Yeah? So a square root is actually give you two answers, a plus or minus 5. Right? You understand that, Ariel?
Yeah.
All right. So just remember that. Now, at the end of the day, oh, okay, somebody dog. Right? So at the end of the day, just remember that this here is a simple little piece of arithmetic. That if you have something squared, then that something will just be the square root. So all I'm saying is that when you apply that to algebra kind of thing, it boils down to being the same thing. It boils down to just being, you know, you have x squared is equal to blah, blah, blah. Then x will be the square root of blah, blah, blah. That's it. You know? Same thing like this. Same thing. Right? So that's what I want to show you guys, that algebra is the same thing as arithmetic. You know, you do it the same way. It's just like any other numbers. Right? We also were talking about the cube roots and fourth roots and fifth roots and sixth roots and all of these kind of things. And we saw a really important rule. And the important rule is you cannot have the square root of a negative number. So if I had the square root of negative 25, this does not exist. You can never, ever, ever have that. And we talked about why. We spoke in detail about it. Right? However, you can have the cube root of negative 25. So you can have a cube root of a negative number, but you could never have the square root. In fact, once this number is odd, then you can have a negative inside of it. But once this number is even, whether it's 2 or 4 or 8 or 6, whatever, once this root is an even root, you could never have a negative in there. We spoke about why, right? So I hope you guys remember. Not Ariel, sorry, Caitlin. Do you remember we doing this?
Yeah.
All right. So you cool with everything here, right? Ariel, are you okay?
Yeah.
Are you just saying yeah?
No.
All right. I have a feeling. Well, let me just see if Ollie just saying yeah. I have 2 questions here. Ollie, I have 5 minutes to do both of them. Right? You have to make B the subject of the formula. 5 minutes. So what's the first thing I should do here? Right? Why I can't transpose the 4AC? It being divided by 2A. And so getting rid of the 2A. So if I transpose the 2A, it'll become 1 multiplied by 2A on the side. And so B squared minus 4AC is equal to that 1 multiplied by 2A, which is just 2A. And now I transpose the minus 4AC, so I'll get B squared is equal to 2A plus 4AC. Now I could leave it like that, but I could recognize that I have 2A as a factor in both of them. So I could pull out the 2A into 1 plus, what is that, 2C? Are these both the same thing? Yeah, you all seeing that, right? And of course, either one is correct. This one is a little nicer though, right? You always want to remove factors and not have common factors between terms. So now you could say that B is equal to the square root of 2A plus 4AC. Ariel, did you get that?
No, I stopped at the second one of children.
And you stop there? Why you stop there? You didn't what? Sorry? Right. No. You didn't have to do this. But at the end of the day, the question was make B the subject of the formula. You don't have B here, you have B squared. Yeah? So what I wanted you to do is move from here to here. You understand?
Yes.
Where B is equal to the square root of all of that. And that is what I was really looking for. Similarly on this side, if it is that I have UT plus a half A by the square root of B, and that is equal to S. First thing is I fling across the UT, so that is a half A square root B is equal to S minus UT. And now I could take the half A, which is being multiplied, and I could fling it across. So now I have the root of B is equal to S minus UT divided by a half A. I'll just leave it like that. Of course, we can simplify it, but that is not the point of this exercise. The point of this exercise is I don't want the square root of B. I want B. So B is equal to all of this squared. Yeah? And that is the whole point. Ariel, you understand this?
Yeah.
Alright, you understand how I went from this line to this line? Alright, lovely. And of course we have some fractions here. Now it have this fraction. Let me ask you something. If you guys had to simplify this, what would you guys do?
Excuse me.
Uh-huh.
Sorry, I just had 2 questions about the last 2 questions.
No problem. Let's just go back to here. Alright, and I just discarded it there. So tell me, what was the question? Well, about which one? About which one?
Both of them actually.
Oh, what was the question?
For the first one, you could just add the 4A and the 2A and make it 6AC.
No, because one of them, and let's just do it. B squared, no, crap. I'll just do it over real quick. B squared, and that's a good question, sir. Minus 4AC all over 2A is equal to 1. B squared minus 4AC is equal to 2A. B squared is equal to 2A plus 4AC. You're saying add these things?
Yeah.
Add these things to get what? What would you get?
AC?
No, because this don't have C in it.
But
So they are not the same, and
yeah.
A is not the same as A times C. Those are two different things. So you can't really do it, but you can recognize that you do have a common term, which is A. So you could factor it out. It's 2A into 1 plus 2C. So 2A times 1 is 2A, and then 2A times 2C is 4AC, and?
Yes, sir.
Right, so this is what you could do. You didn't have to, though. You could have stayed here. You could have stayed here and get your answer. You understand?
Yes, sir.
But this is good mathematics. Right? Same, what was the question with this one?
For that one, instead of putting half A for the answer, I put S minus UT divided by 2A all squared.
2A, it can't be 2A. Right? But, and we'll see why, right? Let's fling this UT across. So a half A root B is equal to S minus UT. Now, this, I'm going to treat this as a single unit. This here is not 2A. Right? This here is actually A on 2. Yeah, I could treat it like that. So I could treat it like A on 2 root B is equal to S minus UT. And now it's multiplied. This A on 2 is being multiplied. So when I remove it, it's going to be divided by A on 2. You understand that?
Yes, sir.
Right? But we could go a step further and say, remember, if you are dividing by a fraction, you're supposed to invert and multiply, and
Yes, sir.
so the root of B now is equal to the S minus UT, all being multiplied by what? Multiplied by 2 over A, and
Yes, sir.
And remember, all of this is over 1, and so I can multiply my numerators and my denominators. And what am I going to get? 2 into S minus UT all over A. And
Yes, sir.
now this is the more correct thing to do than what we did last time. I didn't simplify it last time. I just left it as a half A in the denominator because this simplifying wasn't really the point. The point was to show that all of this squared is equal to B. You understand? All of it squared is equal to B. You okay?
Yes, sir.
All right. So yeah, you'll actually get 2 multiplied by the numerator divided by A. So it wouldn't at any point in time be 2A. Yeah, you're actually changing what it is, right? So so nice. So yeah, coming back to this here now, right? Ariel, you okay with everything we was just talking about?
Yeah.
You don't sound very okay. You sure?
Yeah, I like it. But in my battle, yeah, I had to go over the classes too, so
Yes.
I understand at the point, at this point as you're explaining, but I have to practice as well.
Oh yeah, no, that's beautiful. I love that you said that because at the end of the day, I do explain things very well. But no matter how well I explain things, you had to practice it. You really had to practice it. So how would you simplify this? What would you do?
Multiply x squared everything in the bracket.
All right, so you would expand out the numerator.
Yeah.
Caitlin, what would you do?
Add all the stuff in brackets, then
So you would expand the numerator as well.
yeah.
All right, Shizzy and Ariel, what would you do?
You can cancel off the x's.
Well, no, you can't cancel off the x's, but you're close. right? What you can realize is that x plus 3 is the same number as x plus 3. Yeah, so therefore your answer here is just simply x plus 6, because those two can. So you can't cancel off the x's, absolutely not. Alright, so you really need to go and look over some of them classes, girl. Right? And we will see why. So in this case, these guys will cancel and you'll just get x plus 1. In this case, these guys will cancel and you'll get 1 over x minus 4. This x plus 4 will cancel with one of these x plus 4s. So you'll get x plus 2 into x plus 4 as your answer. So this is a nice little thing that a lot of you guys would have expanded the numerator. But look out for common things that can cancel. Because remember, x plus 3 in brackets represents one number. It doesn't represent two numbers. It represents one number. Yeah? So here, this x plus 2 could go into this x plus 2, right? Because they are both the same number. But you can't look at this 3 and want to cancel it with that 9. No, because this is a different number from this. So that had to stay right there. So this is going to be x minus 3 divided by x plus 9. That is what that's going to be. Right? And maybe we could simplify it further by, actually no, you can't really pull 3 out. So I don't know how we would simplify it further, honestly. Alright, and this x plus 7 will go into one of these x plus 7s, right? So it's a nice little thing that I wanted you guys to look at. And of course we have algebraic fractions, which we did do extensively, right? So we have some questions on that. And now coming up to the more recent classes, we started to look at the laws of indices, and we saw here that, well, these laws are pretty straightforward. Oops, sorry. These laws here are pretty straightforward, and you could probably figure out those laws without even knowing your laws of indices. You could probably figure that out, right? Well, once you know your algebra and you're doing your algebra well enough, you could probably figure that out on your own. But these guys here are very, very useful, especially if you want to get into add math something. Those guys are very, very useful, especially these two. At the CSEC level, these two are good to know, right? All of them, you should know all of them, every single one. And not only know them, but understand them and be able to prove them. Remember, we proved each one of these in class, right? We proved them. So we have the first one here. Now, another thing I want you to remember, that laws of indices only work when the bases are the same. When the bases are the same. Yeah, the same bases. So if I had x to the 4 multiplied by y to the 3, there is nothing I could do with this. The bases are not the same. So your bases have to be the same. And if your bases are the same, when you're multiplying, you add your indices. And this is the proof. Remember, we proved y. We proved all of them, right? If you're dividing, you minus your indices. And this is the proof of y. Yeah? If it is that you have a situation like this, where you have something to a power, and that is in brackets to another power, you multiply your indices. And this is the proof as to why you multiply your indices. Alright? Remember here we had anything to the power of 0 is 1. And I actually asked you guys to prove it in class. And you did. So in class we proved why anything to the power of 0 is equal to 1. We proved it. Yeah? This is a really super important one, especially in CSEC. At the CSEC level, anything to the power of a negative indice is actually a fraction, 1 over that base. So therefore, anything to the power of a negative indice is you put 1 over the positive indice. So if I have x to the power of negative 9, that is the same as 1 over x to the positive 9. The proof, we proved all of it, right? We proved that anything to the power of a half is actually a square root. So a square root is to the power of a half. Yeah? A cube root is to the power of a third. Right? If you have an eighth root, that means to the power of 1/8. So no matter what kind of root you have, no matter what kind of root you have, the q root, that is a to the power of 1 over q. Right? So all of these things, we proved it and we saw it. So this here, the cube root, this is actually 8 to the power of a third. This 5 root here is actually 32 to the power of 1/5. Right? And we saw here that if it is that a square root is to the power of a half, so a square root times a square root will just give you x alone. Because this is to the power of a half, this is to the power of a half, and you see you had to add your indices, so a half plus a half is 1. Yeah? So all of these little things you guys should be really familiar with our laws of indices, and we proved them. This one looks really tough, but it's actually quite easy. It goes back to the square root thing, that if I was to have 5 to the power of a half all squared, right, that is actually the square root of 5 all squared. Yeah, which could actually be seen as the square root of 5 squared, which actually works out to 5. Yeah, so all of these things we did in the classes, and you guys should really get familiar with them. I know laws of indices just seem like a lot. Trust me, we are going to do laws of indices again. When we do Algebra 2, we will do a revision, a detailed revision of the laws of indices, and we'll do over all of them just to make sure that you guys understand it, right? It would have been the 3rd time because we actually did all of the laws of indices twice already. We did it in number theory with normal numbers, and then we did it again in algebra with unknowns. Right? And we'll do it again. We'll do it 3 times because it's worth it. Yeah, and then we have some laws of indices questions here, and then last but not least, we did variation and proportionality. Right? So we saw here that when you have an equation, yeah, y is proportional to 2x, we could see here that y is twice bigger than x. Right? Y is 2 times larger than x. We could see in the table that as x gets larger, y also gets larger, and so they are directly proportional. And we could see that here. Directly proportional means as one goes up, the other will go up as well. Right? We spoke about dependent and independent variables, where we said that x is the independent variable. X could be anything, and y is always dependent on what x is. Yeah, we saw here that you could also have a situation where as x gets larger, y is getting smaller, and when they go in opposite directions like that, we call it inversely proportional. So as x gets larger here, y is actually getting smaller and smaller. So they're going in opposite directions. Oops, where am I? Right. Yeah. So at the end of the day, we saw here that whether you're directly or proportional or you're inversely proportional, you just basically have one method where you get your your relationship, right? So if y is directly proportional, so that is the relationship. The relationship here is y is directly proportional, right? We could see it here as x gets bigger, y will also get bigger. So that is what directly proportional means. Once you have your relationship, then you could form your equation, right? And the equation must have your k, your constant of proportionality. And once, same thing with the inverse, that if y is inversely proportional to x, then you just form your equation using your constant of proportionality, where k is the constant of proportionality, right? Ariel, you remember this? We did this, I think you were here, right?
Yeah, I was in that.
So you're cool with this stuff, right? Now, take a look at this, and you guys, somebody tell me, is this directly proportional or inversely proportional?
Sorry.
Very good. We could see here, we could see here that as x is getting larger, y is also getting larger. So what they're asking us to do here is to form an equation that will describe this relationship. Well, the first thing is we recognize that it is directly proportional, and therefore we state the relationship. Y is directly proportional to x. Once we state the relationship, well, then we could say, all right, the equation is y is equal to kx, where k is the constant of proportionality. And now we could find what k is, because look, we have many different values for y and x. So let's just say that when x is 2, y is 6. So now we have values for x and y. So we can actually plug it in. When x is 2, y is 6. And therefore we will get k to be 3. And so the actual specific equation that describes this relationship is y is equal to 3x. And that is your answer. So Ariel, Shazay, you guys, Caitlin, you okay with this? So yeah, that is our review of the introduction to algebra, and you could see that it was much deeper than just an introduction. Yeah, we actually went pretty deep into algebra. We didn't do things, it have other algebra things that we will do in algebra 2. So in algebra 2, which we'll probably do next year, that will involve quadratic equations, that will involve simultaneous equations and this kind of thing. Usually, because we started from scratch, so usually you're not supposed to do algebra so early in the curriculum. But what I did, I chose to do it differently this time. I chose to do, because one of the biggest things that I noticed with students is that you guys don't realize that algebra is the same thing as arithmetic. You're multiplying the same way, you're adding the same way, you're minusing the same way, you're doing everything the same way. Fractions and things too. So what I wanted to do is I wanted to give you guys started you off with number theory, and we went through all of the SCA number theory, adding fractions and all of these factors and multiples and all of these kind of things. And then right after we do algebra, and I showed you guys how everything that we did in number theory, we just do it over the exact same way in algebra. The only difference is that we have unknowns. And a lot of students will see X and get afraid and not realize that X is just another normal number, and you treat it like a normal number. So that is what I hoped to get across to you in the introduction to algebra. That algebra is the same as arithmetic, you treat it the same way. Right? So this Saturday you will be getting your algebra exam. Right? The exam, I think I might make it a multiple choice, I don't know. But one of the things that I might do as well is I might give you guys full CSEC questions. Yeah? So only CSEC questions, and you'll see that the CSEC questions are a lot easier than the questions that I just be giving here. Yeah? Even the laws of indices questions are a lot easier. There wouldn't be anything like the stuff I gave you. Right? So what we'll do is this Saturday you'll get your exam, and that exam will be based on everything, and not just algebra. It'll be based on number theory as well. So you'll be getting number theory questions and algebra questions as well, right? Then next Tuesday we will correct the exam, and we will also correct those outstanding variation and proportions questions that we have to finish off. Yeah. So Saturday is the exam. The next Tuesday will be a full day of doing questions, and then the Saturday after that is where we will get to start our new topic, which will be sets. It's either sets or coordinate geometry. I'm still trying to decide which one we're gonna do, and most likely sets, because sets real easy. Yeah, just clear that out real fast. Right? So. That is it for the introduction to algebra. Good luck in the exam. Anybody have any questions or anything? Right. Well, if you don't have any questions, it was lovely seeing you guys. I really wanted to over early today, and we only ended up over in 10 minutes early. Oh, one more thing. Those slides that I was just presenting with, if you look in your Google Classroom, I'll show you guys where. If you look in your Google Classroom under Intro to Algebra, right? Well, first of all, this is this class 16 here. This is last week's class. It's only 15 minutes. That is where I corrected some of the variation and proportionality questions. I didn't correct all, I just corrected the first section. I kind of wanted you guys to be there for the second section. But the intro to algebra review, which is, ooh, look at how people tuning that boy, very nice. The intro to algebra review is what we were just looking at, and these are all of the slides here. Algebra 1, Algebra 2, laws of indices, variation and proportionality. So you could go and look at these slides, and these slides basically is a summary of everything that we did in the past 10 classes. We had 10 classes in this topic here, right? So, nice. If it is that you guys have no questions, it was nice seeing you all, and I'll see you all on Saturday.